Welcome to month 6 of the Architect track, the Capstone session. This month is titled Architecture Governance and Standards. Everything you have built across the previous 5 months, systems thinking, solution design, cloud architecture, operational excellence, vision and influence, converges here in the discipline that determines whether excellent individual architecture decisions produce an excellent organization at scale. This session covers 5 interconnected objectives: creating comprehensive governance frameworks, establishing organization-wide technology standards, designing and operating an architecture review board, defining architect career paths and competency models, and, critically, balancing governance with innovation so that the system you build enables teams rather than constraining them. The format is 4 hours of theory, hands-on challenge work, and peer review, with 6 deliverable documents. This is not a theoretical exercise. Every artifact produced today is a document a real organization could pick up and operate. The 4 hours are structured in 3 phases. Hour 1 establishes the theoretical foundation: governance principles and anti-patterns, standards as enablers, rather than blockers, ARB best practices, and a 20-minute cognitive exercise on exception handling, a real scenario that calibrates the quality of your decision-making before the main challenge begins. Hours 2 and 3 are the hands-on challenge: 4 sequential parts covering a governance framework, a technology standards document, an ARB charter and review process, and an architect career development system. Each part has a hard time box. The constraint is intentional. Governance frameworks that are not pressure-tested tend to be comprehensive, but impractical. Hour 4 is peer review and program retrospective. 8 minutes per participant to present the full governance system, followed by peer critique and a reflection on 6 months of architect training. Consider TechScale, a growing technology company with 500 engineers and 50 teams. Without formal governance, the organization accumulated 8 front-end frameworks, 12 database technologies, 4 message queuing systems, and 5 independently built internal authentication systems, all in production simultaneously. That accumulation was not a failure of individual judgment. Each choice seemed locally reasonable. The failure was systemic. There was no mechanism to coordinate decisions across teams, and so the organization paid the compound cost of every redundant choice, every knowledge silo, and every security gap. The results were predictable. Engineers could not move between teams because every team ran a different stack. Security implementations were inconsistent, leading to a breach. Auditors found undocumented architecture decisions everywhere they looked. With governance in place, those same 50 teams can operate on common patterns, share libraries, and make decisions once that previously each team resolved independently. Risk becomes auditable. Staff can move where the work demands it. This is the case for governance, not compliance theater, but the operational infrastructure that lets a large engineering organization move fast and coherently. The design goal is autonomy aligned to accountability. Maximum team freedom within a structure that protects the organization. A governance framework is only as strong as the principles that underpin it. Principles are not slogans. They are decision-making guides with stated rationale, implications, and explicit exceptions. The template on this slide captures the structure: principle name, 1-sentence statement, the rationale that explains why it matters, the implications for teams, and the conditions under which the principle may be relaxed. 10 principles anchor this framework. Security by default means security is designed in from the start. Every new service must meet baseline security requirements before deployment, not as a pre-launch checklist. API first means the contract is defined before the implementation, and internal consumers are treated with the same discipline as external ones. Build for observability means every service must emit structured logs, metrics, and traces. You cannot operate what you cannot observe. Prefer composition means favoring proven components over building new ones and requiring a clear differentiation argument for from-scratch builds. Team autonomy with accountability means teams own their architecture decisions within standards, freedom in how, accountability for outcomes. Reversible decisions is one of the most underused principles in practice. Prefer two-way doors, and when facing genuinely irreversible decisions, escalate scrutiny proportionally to the cost of reversal. Data as product, documentation as code, performance by design, and by vias build rigor round out the set, each encoding an organizational commitment that teams can apply independently without asking for guidance. The anti-pattern to name explicitly is governance theater. Processes that produce paperwork but no decisions, reviews that never say no, standards that no one follows. The measure of governance is outcomes, not activity. Architecture decisions in a large organization need a clear escalation structure, not to create bureaucracy, but to ensure each decision is made by the right people at the right altitude. A 4-level decision model accomplishes this. Level 1. Team decisions. Implementation choices within the approved stack. No approval required. The team owns the decision and owns the outcomes. Level 2. Domain architect review. Decisions that create cross-team dependencies, introduce new library selections, or affect shared data models. This is peer review, not approval, and it should be fast. Level 3. Architecture review board. New technologies not on the approved list. Cross-domain architecture. Security-sensitive changes and decisions with significant cost impact. This is where formal governance applies. Level 4. CTO escalation. Strategic technology shifts, vendor relationships, compliance commitments, and budget above a defined threshold. The ARB is composed of a permanent chair, the chief architect, 3 permanent senior architects on 2-year terms, 2 rotating domain architects on 6-month rotations, and invited domain experts per topic. Quorum requires the chair and 3 members. The critical design principle. Most decisions should never reach the ARB. If the ARB is a bottleneck, the standards are too narrow. Calibrate the authority levels quarterly based on how frequently each level is invoked. Technology standards are the primary output of architecture governance. They encode the organization's technology choices in a form that every team can operate against daily, without needing to consult an architect for routine decisions. The 5-category taxonomy is more useful than a binary approved or not list. Preferred technologies are the default choice with full internal support. Java 21, TypeScript, React, PostgreSQL, Redis. Approved technologies are allowed with standard support. Python for data and ML workloads. Go for performance-critical services where the team has the expertise to support it. Emerging technologies are in evaluation for limited use, promising, but not yet at production support level. Tolerated technologies are legacy systems being phased out, allowed to continue with existing use, but not eligible for new projects. Prohibited technologies are not allowed on any grounds, typically due to security vulnerabilities, compliance exposure, or support end of life. The table on this slide shows the practical output: technology name, classification status, appropriate use case, and the specific constraint that applies. React is preferred for all new front-end projects, but exceptions require ARB approval. Go is approved but requires ARB review before adoption. because the constraint is not technical but organizational, related to expertise availability and hiring implications. Ruby and PHP are tolerated for legacy systems only, with a migration plan required for anything that uses them. Standards without constraints are not standards, they are suggestions. A technology standards document that is published once and never updated is not governance, it is archaeology. Standards require a lifecycle, a process for adopting new technologies and a process for sunsetting legacy ones. The adoption process runs in 4 stages. Proposal in week 1 is an RFC submitted to the architecture channel with a documented use case, benefits, risks, and a sponsor team that has committed to an initial implementation. Evaluation runs for 2 to 4 weeks and includes technical assessment by a domain architect, security review, compliance check, and a proof of concept if the risk profile warrants it. ARB decision is the formal gate. The evaluation results are presented, the board votes, the decision is documented in an ADR, and the technology is assigned a position on the tech radar. Onboarding is the stage most often neglected. The technology is added to the approved list, a getting started guide is created, templates are updated, and training is scheduled. A technology that is approved but has no onboarding support will not be adopted at scale. The deprecation timeline runs on an 18-month clock. At day 0, deprecation is announced with the rationale and the migration path. At 6 months, soft deprecation begins. No new projects may use the technology, but existing use continues with migration support available. At 12 months, hard deprecation begins, active migration is expected, and continued use requires explicit risk acceptance. At 18 months, the technology is prohibited and remaining usage is tracked as technical debt requiring remediation. The tech radar is the public face of the standards, updated quarterly, visible to the entire engineering organization, and searchable. If the radar is buried in a wiki that requires 3 navigation steps to reach, it is not doing its job. The Architecture Review Board is the operational mechanism that makes governance real. Without a charter, an ARB is just a recurring meeting. The charter defines what the ARB is for, who participates, how decisions are made, and crucially, what the ARB does not cover. The ARB's purpose is to ensure architecture decisions align with business strategy, manage risk, maintain standards consistency, and enable sustainable technical evolution. Membership follows the structure described in the governance section. A permanent chair with casting vote, 3 senior architects on 2-year terms, 2 rotating domain architects on 6-month rotations, and invited guests per submission. Meeting cadence uses 3 formats calibrated to decision complexity. The async review window handles standard patterns. Submit an ADR to the architecture channel. Allow 48 hours for feedback. Auto-approve if no blocking concerns are raised. This format should handle the majority of submissions. The sync review handles significant decisions. A 30-minute presentation followed by 15 minutes of discussion with the decision documented same day, and a 1-week turnaround SLA. The deep dive handles major changes that require 2-hour workshops, scheduled separately with a first session SLA of 2 weeks. Decision criteria are weighted across 5 dimensions. Technical soundness at 25%, security compliance at 20%, strategic alignment at 20%, cost and team capability at 20%, and operational readiness at 15%. The anti-pattern to design against. If teams are waiting weeks for ARB approval, governance is blocking delivery rather than enabling it. The target is 80% of decisions handled below ARB level. When ARB becomes a bottleneck, the triggers are too broad, not the process too slow. Architecture decision records are the institutional memory of the governance system. Every significant decision, a new technology adoption, a cross-team dependency, a breaking API change, gets an ADR. Without ADRs, decisions are made and forgotten. Future engineers encounter the consequences without access to the reasoning. Knowledge leaves when engineers do. The ADR template captures 8 elements. The number and title uniquely identify the decision. Status is one of 4 states: proposed, accepted, deprecated, or superseded. Context describes the situation that made a decision necessary. Decision drivers make explicit the forces shaping the choice: performance requirements, security constraints, team capability, timeline. Considered options documents the alternatives evaluated, not just the one chosen. An ADR with a single option recorded is a signal that alternatives were not genuinely considered. The decisions section states the chosen option and its rationale. Consequences captures the trade-offs, positive, negative, and neutral, of the decision taken. And the compliance section records the security review status, data governance implications, and performance requirements assessed. ADRs live in a structured repository: accepted decisions, proposed decisions under review, and deprecated decisions that have been superseded. The patterns library organizes reusable solutions by domain: API patterns, data patterns, integration patterns. The tech radar is referenced from the standards directory. Approval thresholds are scored on a rubric. A score of 4.0 or above means approved to proceed. 3.0 to 3.9 means conditional approval with specific concerns to address before proceeding. Below 3.0 means not approved, with a requirement to revise and resubmit. Governance without enforcement is aspiration. Compliance at the scale of 50 engineering teams requires automation. Human review cannot scale to every pull request, every deployment, and every dependency update. The CI/CD pipeline is the primary enforcement surface. 5 automated checks form the baseline. Dependabot monitors dependency versions and blocks pull requests when known vulnerable versions are detected. SNCC scans for security vulnerabilities and blocks deployments when critical issues are found. Spectral lints API contracts against the documented standards and surfaces violations as pull request comments, visible, but not blocking, because API standards require interpretation. Trivi scans container images for compliance and blocks deployments on critical findings. SonarQube enforces code quality gates and blocks pull requests below the defined threshold. The audit schedule complements automated detection with periodic manual review. Quarterly automated compliance reports produce a technology inventory, detect drift from approved standards, and scan for known bad dependency versions across all services. Semi-annual manual audits review ADR completeness and spot check standards adherence, the things automated tools cannot assess. Annual external audit support produces the evidence package required for compliance certification. The shift-left principle governs the entire enforcement design. Every compliance check that runs in continuous integration saves 10 times the cost of discovering the same issue in production. Automate everything automatable. Reserve human review for judgment calls that require context, the kind of context only an architect can bring. The architect career ladder defines 5 levels of progression from associate architect to chief architect. Each level is differentiated by scope of influence, decision authority, required experience, and the balance between technical depth and leadership capability. At level 1, the associate architect operates at single team or single service scope. The role requires 5 or more years of engineering experience with at least 1 year of architecture exposure. Key responsibilities are service-level architecture decisions, ADR authorship for the team, and mentoring senior engineers. The competency profile sits at technical depth, 3 out of 5, leadership at 2 out of 5. This is an engineer expanding into architecture. At level 2, the architect expands to multiple teams or a product domain, 7 or more years of engineering experience, 2 in architecture. Cross-team decisions, domain-level standards ownership, and ARB participation. Technical depth rises to 4 out of 5, business acumen to 3 out of 5. At level 3, the senior architect operates across multiple domains and at org-wide scope. 10+ years of engineering experience, 4 in architecture. Enterprise architecture decisions, technology strategy ownership, ARB leadership, and engagement with executive stakeholders. Both technical depth and leadership reach 4 out of 5. At level 4, the principal architect operates at organization-wide scope with industry influence. The role requires 12+ years of engineering experience and ownership of the technology vision. All competency domains reach 4 to 5 out of 5. At level 5, the chief architect is a member of the executive team with enterprise scope accountability and external industry thought leadership. 15+ years of engineering experience, 8 in architecture. All competencies at 5 out of 5. This level represents the architect as a business leader who happens to hold deep technical authority, not the reverse. The architect competency model structures assessment across 4 domains with explicit weightings that makes something visible, which is usually left implicit. 60% of what makes an effective architect is not technical. Technical depth at 40% of the assessment covers system design, technology breadth, security architecture, and cloud architecture. These are assessed through design reviews, technical interviews, security reviews, and infrastructure reviews, observable outputs, not self-report. Business acumen at 20% covers industry knowledge, business model understanding, financial literacy, and customer focus. An architect who cannot build a financial model for a technology investment or articulate the commercial implications of a technical decision is operating at reduced effectiveness, regardless of their technical depth. Leadership at 20% covers influence without authority, decision-making and ownership of outcomes, mentoring, and conflict resolution. Influence is assessed through 360-degree feedback from peers and stakeholders because influence is a relational quality that cannot be self-certified. Decision-making is assessed through the quality of ADRs produced, a visible, concrete output. Communication at 20% covers stakeholder management across diverse audiences, written communication, presentation skills, and the ability to translate technical concepts into business language. An architect who cannot explain a technical risk to a CFO or a compliance officer cannot fully perform the governance role. The annual development cycle runs across 4 months. Self-assessment in month 1, 360-degree feedback from 3 to 5 peers, and 2 to 3 stakeholders in month 2, manager calibration in month 3, and a development plan with mentor assignment in month 4. The cycle closes with a development plan that is specific, measurable, and connected to identified gaps, not a collection of aspirational intentions. The most sophisticated governance system fails if it produces the wrong culture. The left column of this slide is a diagnostic checklist of governance gone wrong, patterns that are distressingly common, and that any architect who has spent time in a large organization will recognize. Approval theater. Every decision requires ARB sign-off, teams wait weeks, and engineers begin finding ways to frame decisions as implementation details to avoid the process entirely. When engineers root around governance, governance has failed. regardless of how thorough the process looks on paper. Standards overreach. Prescribing implementation details inside service boundaries removes the team judgment that makes technical ownership meaningful. Standards should define outcomes and interfaces, not internal implementations. Frozen standards. A technology radar that is 18 months stale is not governing. It is preserving the choices of a past moment against the needs of the present. Standards that cannot evolve will eventually be ignored. Zero exception culture. Reflexive denial of every exception request does not protect standards. It trains engineers that the governance system is an adversary. The exception process is a safety valve and a learning mechanism. A governance system without one is brittle. The right column shows the corresponding enabling patterns. Paved roads, not walls. Make the compliant path the easiest path through excellent templates, fast approvals, and pre-built patterns. Structured exceptions. Clear criteria, documented evaluation, time-boxed decisions that feed back into the standards. Living standards. Quarterly tech radar updates, annual standards review, an RFC process that gives any team a legitimate path to propose changes. Sandbox environments. Designated teams can run limited proofs of concept with emerging technologies, with results shared with the ORB. The design philosophy is captured in one line. Governance succeeds when engineers say it helps them, not when architects say it is thorough. The first exercise is a structured exception evaluation. A development team at TechScale, the customer experience team, has requested permission to use Solid.js for a new self-service portal instead of React, the approved standard. Their case is technically credible. Solid.js produces a 40% smaller bundle with demonstrably better rendering performance. The concern is also credible. Solid.js has a smaller ecosystem than React. Fewer engineers in the organization have experience with it, and adopting it creates a dependency on a framework with a smaller community and a less mature hiring market. The 5-step exception process begins with defining evaluation criteria before scoring the specific request. The criteria should be explicit and weighted. Technical merit, ecosystem maturity, team capability to support the choice long-term, organizational impact on hiring and staff mobility, and strategic fit with the direction the organization is moving. Establishing criteria first prevents the evaluation from being shaped by the desired conclusion. Step 2 scores the request against each criterion with documented evidence. Step 3 requires a decision: approve, deny, approve with conditions, or initiate a formal evaluation to elevate Solid.js to the emerging category on the tech radar. Step 4 documents the decision with full rationale in an exception ADR, including any conditions and a review date. Step 5 generalizes the process. Every exception request is an opportunity to refine the exception template, so the next request requires less process overhead to evaluate. The deliverable is a governance decision framework document, reusable for all future exception requests, not specific to Solid.js. TechScale Enterprises is a pre-IPO B2B enterprise software company with 500 employees, 200 engineers, and 50 engineering teams. Revenue is $100 million annually. The technical estate comprises 150-plus microservices running on a mixed stack of Java, Node.js, Python, and Go. The company has grown fast enough to build significant scale, but not fast enough to establish the governance that would make that scale sustainable. The current state is a governance vacuum. 8 front-end frameworks are in production simultaneously. 12 different database technologies. 5 independently built internal authentication systems. 5 teams solving the same problem without coordination. a security breach due to inconsistent implementation practices, a failed compliance audit, a 4-hour production outage. The CTO's mandate is clear: enable teams to move fast while maintaining quality, security, and consistency. The challenge produces 4 artifacts over 120 minutes. Part 1, 35 minutes. An architecture governance framework covering principles, decision structure, and governance processes. Part 2, 30 minutes. A technology standards document with 5-category classification, adoption lifecycle, and compliance enforcement. Part 3, 30 minutes. An ARB charter, ADR template, review criteria rubric, and knowledge management system. Part 4, 25 minutes. A 5-level architect career ladder, competency model across 4 domains, and an annual assessment framework. The success targets are measurable: reduce technology sprawl by 30%, achieve zero compliance failures, meet the ARB response SLA, and improve engineer satisfaction scores. These are the outcomes governance exists to produce. Parts 1 and 2 establish the governance foundation. Part 1 covers the governance framework in 3 tasks. Task 1 requires 10 or more governance principles using the standard template, including security by default, API first, observability, composition, data as product, team autonomy, reversibility, BIVS build, documentation as code, and performance by design, plus 2 to 3 principles that are specific to TechScale's situation. The 5 duplicate auth systems and the 8 front-end frameworks are symptoms of missing principles. What principles would have prevented them? Task 2 designs the governance structure, ARB composition, a decision authority matrix that maps decision types to team ARB or CTO authority, an escalation path, quorum requirements, and rotation policy for domain architects. The design challenge is creating authority boundaries that are specific enough to be operational but flexible enough not to require constant renegotiation. Task 3 designs governance processes, 3 review types with defined triggers, submission requirements, and SLAs for each. When is a review mandatory? The trigger criteria are the boundary between L2 domain review and L3 ARB review. They need to be precise. Part 2 covers technology standards in 3 tasks. Task 4 produces the standards document, languages, frameworks, databases, infrastructure, and API standards, each classified across the 5 categories. Task 5 designs the standards maintenance system, the 4-stage adoption process, the 18-month deprecation timeline, and the quarterly tech radar update cadence. Task 6 maps automated compliance checks to enforcement actions and defines the audit schedule. The key tension to resolve in Part 2: too few standards produce chaos, too many produce rigidity. The right calibration depends on team count, risk profile, and the maturity of the engineering organization. Parts 3 and 4 complete the governance system with the ARB's operational charter and the human infrastructure of the architect career path. Part 3 covers the architecture review board in 3 tasks. Task 7 is the ARB charter, purpose, scope, including what the ARB explicitly does not govern, membership composition with selection criteria and term limits, meeting cadence, quorum rules, decision-making process, and an appeals process for rejected submissions. A charter without an appeals process is incomplete governance. Task 8 defines the review process, the full ADR template, a review criteria rubric with explicit weights, and approval thresholds, 4.0 or above approved, 3.0 to 3.9 conditional, below 3.0 rejected and requiring revision. The rubric makes the criteria transparent and the scoring consistent across reviewers. Task 9 designs knowledge management, the ADR repository folder structure, an architecture catalog covering all services with owners and health status, and a pattern library organized by domain. The design goal is that a new engineer joining TechScale can find the answer to any architecture question without asking a colleague. Part 4 covers architect career development in 3 tasks. Task 10 defines the 5-level career ladder, associate through chief, with scope, experience requirements, responsibilities, and competency rating targets at each level. Task 11 defines the competency model, 4 domains with weights and subcompetencies, each with a defined assessment method. Task 12 designs the annual assessment cycle, self-assessment, 360 feedback, manager calibration, and development planning, each with an owner, a timeline, and a specific output. The career ladder principle: vague levels do not help architects grow. Observable behaviors and measurable outcomes at each level are the standard. The 6 deliverables represent a complete governance system for TechScale. Each is weighted to reflect its relative importance and complexity. The architecture governance framework at 25 points is the highest weighted deliverable because it is the foundation everything else builds on. Completeness of principles, structural clarity, and, critically, genuine balance between autonomy and control are the assessment dimensions. The technology standards document at 20 points is assessed on how comprehensive, practical, and maintainable the standards are. A standards document that a team cannot use daily without consulting an architect to interpret it has not succeeded. The ARB charter and ADR process, also at 20 points, is assessed on clarity of authority, process efficiency, and the quality of the knowledge management design. The architect career ladder at 15 points is assessed on the specificity of level definitions and the measurability of the competency model. The exception handling process from the cognitive exercise at 10 points is assessed on the quality of the decision framework, its generalizability beyond the solid JS case. Presentation quality at 10 points is assessed on clarity, structure, and stakeholder focus, the ability to communicate a complex governance system in 8 minutes to an audience of peers. The final score bands range from 90 to 100, exceptional, ready for an architect role, down to below 60, indicating significant gaps requiring further development. A score of 80 or above indicates readiness for an architect role, with the 80-89 band reflecting strong performance with identified development areas. Architecture governance, done well, is what enables 200 engineers to move fast together, consistently, safely, and in a direction that serves the business. The 4 artifacts produced today are not bureaucratic artifacts. They are the operational infrastructure that replaces daily individual decisions with durable institutional knowledge, a framework of principles that guides without prescribing, standards that encode the organization's best judgments, an ARB that resolves ambiguity efficiently, and a career ladder that develops the architects who will maintain and evolve the system. The measure of this work is not the thoroughness of the documents. It is whether, 12 months from now, TechScale's engineers would say the governance framework makes their work easier. Governance that earns that answer has succeeded. Governance that earns the opposite, that engineers root around, criticize in retrospectives, or simply ignore, has failed regardless of how comprehensive the documentation is. The closing principle: governance succeeds when engineers say it helps them, not when architects say it is thorough. The 6-month architect track is complete. The offline milestones that follow, establishing an ARB, launching strategic technical initiatives, building a community of practice, publishing thought leadership, are not extensions of the training. They are the architect's actual work in the real organization starting now.